The next tool that we'll have a look at is CloudCompare. I find this to be a lot more flexible in terms of being able to clean up the noise in an automated way, as well as having some of the tools to kind of do that manually as well. So we'll just drag all of our files in there, just do an apply all. So you can see it's kept the alignment that we put together from that cloud matching in JMStudio, so everything's still aligned nicely. You can turn off each layer individually to see each scan and how they build on top of each other. And what we'll do is go through and add some noise cancellation to those as well. See, there's two different types of noise cancellation here in CloudCompare. The main one that we'll use is the SOR, so standard outlier filtering. Statistical outlier filtering, sorry. We've got a couple of different points that we can change in there. So the main thing that we're looking at is how far apart or how many points in a given region are we comparing against the standard deviation to find out if they're noise or not. And then the second one is the multiplier for the standard deviation itself. So you can see, turning off the original scan, we get an idea of how clean or not clean it is. Once we're happy with some of those values, we can go through and change those as well. So bringing down that standard deviation will actually increase the amount of noise that's removed. So it's really just a matter of going through and testing those settings. You can delete the attempts that you've made in there, so all those point clouds are stored on memory until you export it, so it's quite quick to come in, bring them, turn them on, turn them off, create, delete them. It's quite a useful tool for doing that stuff quickly. So we'll just try that again. In this case, there's a little bit too much removed. We'll change the values on here, do another test. And depending on the density of your model, I've tried everything from kind of 8 or 9 points in a calculation up to 50-60, just depending on what the variation in densities between certain areas of your scan are. As you can see though, that's removed a bit of extra information around the middle of the model, but the main features are still there. Some of the points around the wing that were garbage have come off, so that's nice to see. So just running through, we can select multiple scans and apply those same values across each of them. So you will get a better result if you kind of run through scan by scan, just because they're all different in terms of their densities, lighting, the angle that you might have had the scanner at, so you're best off going through and doing them one at a time. But just as an example, I thought I'd run through with the same details. So just again, ticking the ones that we've just created, the clean ones, we should get an idea of what our merged point cloud is going to look like. So you can see there's still definitely some garbage data around the model, which is similar to what we saw when we meshed it in reverse scan. A lot of that rubbish was removed automatically, along with a lot of the detail by JMStudio. So just setting up to remove a bit more information where we can see those parts that are particularly problematic. Probably run through in a separate tutorial just how to do some manual cleanup in here. You'll find that you won't ever get quite perfect unless there is a big variation between your noise and your model, but it's really a matter of going through scan by scan, especially if you kind of did that, apply the same settings to all of them, find out which one can be tweaked to get you a better result. Once you're happy with it, what we can do is just merge. So in general, you won't want to keep this. Yeah, we probably shouldn't have kept that extra information about the cloud. It's not particularly useful. It just gives color information in terms of the scan points themselves, which we're probably going to delete straight away anyway. You can kind of see where those points came from. This panel is quite useful when we're running through the actual meshing algorithm. So you find that here under this PoissonRecon. and there's a few different fields to set. The important one there is that output intensity coming out as a scalar field. You'll use that to remove sections of the model that are auto-generated to create a clean mesh. You can see there's some help in here. The main ones that you want to change is that samples per node. You can see that's changed particularly dependent on whether your original mesh has a lot of noise or not a lot of noise. So kind of that 1.5 to 5 region for a clean model, and then kind of 10 to 20 if it's much higher. See, it's fairly resource intensive, less so on the memory but more on the CPU, but it's quite a quick process depending on the level of reconstruction. So as you can see, I picked a level 10 there, which is fairly resource intensive. You generally want to stay kind of 8-9 region unless you need a lot of extra detail. Once you go over 10, the process takes a lot longer. Over 12, kind of 13 up, I haven't found too much value in it. It takes a lot longer and the result isn't too much better. See, even with all of that stuff happening in memory, it's a lot lower memory resource usage than either JM or RevoScan. So you can see that's now generated a mesh there at the bottom, so we can turn off the original points that we generated it from to see kind of what the result looks like. As you can see, it's a lot cleaner than what we were getting in RevoScan. A lot of those details are still there that we're looking for, so the creases in the hull, etc. So the scalar field is this used for this section at the bottom. So you can see as we drag that from left to right, the blue areas areas that were non-existent, so generated by the trying to fit a mesh across the points, and the red areas are kind of the very dense sections of your model, so there's a lot of points there. They'll be a lot closer to what you expect. So the more you increase the range out to the left there, the more it'll fill in holes and create details, but I guess the less correct it'll be in terms of the main thing that scalar field shows is how far away from the original point cloud parts of the mesh are. So the blue sections aren't close to many points because there might have been holes there or sections that you're trying to get rid of. Turning on the points, you can see, yeah, those really sparse parts of the point cloud are the pieces that will be holes in the model. If you haven't got a completely enclosed scan, you'll find a few more problems running through that, in which case you might want to take out more of the blue sections. So just for the case where we're not happy with what the mesh looks like, if we're finding there's still too much noise, I just thought I'd go through in brief detail how to clean it up. So first things first is just selecting the model that you're wanting to work through, making sure that it is the one that's got the points that you're trying to clean up. You can find here some that I've done a little bit earlier. So starting with the original mesh, taking out some of the points that we can see are problematic, particular angles, making sure you look at the model from all sides. One of the important things when we're looking at removing the statistical outliers from the mesh, so those noisy points, is the most important thing is the density of the mesh itself. So if you're finding that you've got a scan that has a mixture of densities, it's definitely something you want to look at. So if I look at this hand scan 5, these other ones off so I can see it in isolation. I see certain features like the top of these rifles at the top, or guns, blasters, whatever it is, has a lot lower density than the bottom half. So if we're using something like the SOR filter on this, you'll find that we might lose what small information we do have on that at the top, and you'll probably see that in the final model that we looked at earlier, just those holes that have been taken out by us. So I guess one item that you've got, or one option you have there, is to select subsets of the models so that you have less variation in the densities. Say for example I'm trying to get rid of the points off the bottom of this model. You can see it's quite a clean mesh, and whereas over here there's not quite as much meshed information. So if I include any of this side when I'm running this, the SOR filter, it'll take out all of the information around this top half. So to do that, I'm going to select a subset of the model to work on. So you can see the cut tool at the top here. You can see the instructions there. Hold Alt and click around. So in that way I could select just the areas that have that lower density mesh, and if I take this as an example, it's not going to take that really high density mesh from the bottom and remove these really low points that are between the garbage and the rough data that we actually want to keep. So what we can do with that cut tool, you can see there's two options at the top here. One is segment out and segment in. That'll just say which piece of the model becomes the starting point. So if I go segment out for this, you see it cuts it out of the existing model. When I hit the tick button, I'll end up with two pieces, so the piece that was there before and the piece that I've segmented out. So what that'll let us do is run our filter on this item in isolation, so we should have less of a problem with variations between the two parts of the mesh. So if I just come into here, I'll lower this down a bit just because there aren't as many points in the mesh, and I'll bring this up to something like a 2.0. Running that, we can then see what we had. This is what we have now, so you can see it moves some of those white points. Probably not enough in this case, so we'll just delete that one. Try again. So again, selecting the one that you're running the filter on, bringing this down, say to a 0.9, and running it. You can see a lot more of those points that were garbage at the top there have disappeared, which is really what we were looking for. So feel free to play with that as many times as you want, so these points are all in memory, so you don't have to worry about it being slow writing to disk, etc. Turn it on so we can see it, not that you necessarily need to. If we try that again. And this is all based on the standard deviation, so by taking out that really dense area, we're basically putting that standard deviation more in line with the area that we're working on rather than the entire model that's varying. Run that again. To me that looks much better. So then what I typically do is, once I'm happy with that, just delete the original remaining section. So the segmented piece is the piece we chopped it out of. So if I delete the original remaining that hasn't been cleaned, I can then take that cleaned portion and essentially reattach it to the model just by merging the two together. So you just select those two, click the merge. You don't need the scalar field, I haven't found a use for that yet, but essentially then we've cut the points out of just that piece of the mesh that we were worried about without impacting on everything else. So again, you could go through and do the same thing on these guns to get the areas around it. Certain items like here, between the top of the model and I guess that gap between the two areas there would be a good candidate for working with, and I'll basically go through and do that on various items that look like they're out of place. That cut tool is also really useful for just chopping out sections. It's quite similar to the one that you'll find in JMStudio, but it's a little bit easier to work with, that you can separate pieces out, put them back, and it's a bit more controlled in that way. So again, you could do the same thing even if you just wanted to chop a point out completely and not bring it back in. Again, press O to cut that section out. You can then press space to unpause and select another section, so you can basically do that in multiple phases as well. Right click to stop selecting, press O to add it to the selection of items that you're removing. You can then move the model around until you're happy with an area that you're trying to cut out. And again, press space to start again, press Alt to start a new selection. And basically work through all of your scans in that way. You could probably do it as one mesh if you wanted to, so merge them all together and do it in that way. I just find it a little bit easier to see what I'm working on if I do it on smaller sections instead. Again, the angles are really important for these items as well. So if I look at this, whereas if I brought down to this angle, there's actually detail in there that I want to keep. So just rotating it, you'll find that there's particularly points that need to be removed off any corners of the model, so they'll get reflections as the scanner goes across it. So getting to an angle where you can see just the points that are above that edge can be really useful. Let me do the ones down on that ball as well. So again, space to unpause, Alt to start. I find that this polygon tool is a bit easier than trying to draw a line if you've got a bunch of fairly straight angles. You don't have to be quite as precise with the mouse. To this side as well. You don't have to get all the points, of course. You can use some of the noise removal tools that we've already seen to do that, but every bit helps. Cool, so again, we can see the piece that we've segmented out and the piece that was there originally, so in this case we'll just get rid of the segmented. We'll find that's much cleaner. So you can run through model by model and do that. Spend as much time as you need to get a cleaner output. Pretty happy with that for part 4. Again, it's just an example. It's not going to be perfect. But if we select that again, there's probably some points in here we can just cut out to make our life easier. Model's a little bit messy still, so I just want to do that here. A little bit dangerous doing it from this angle because you could delete some detail that's further across. Given we've got a few other scans, we're probably pretty safe. Again, near enough is good enough. Again, some noise that we're removing, don't need to keep it, so I can delete that. So then I'd go through and use the SOR filter to take out some of the larger sections of noise that we don't need. It's one more that I'll probably just fix up because it's going to be a pain. Again, cut tool, start, cut, bring it across. Anything that's a rather large section like this one that might be seen as an extra piece of the model is worth getting rid of because they're definitely the ones that hurt you in the long run. Okay, that looks pretty good. Cool, so again, that's just the piece we've cut off, so that can go, delete. And then we'd run through and run some of the noise reduction filters for those smaller areas. Anything that's really close to the body, close to some of the detail, it's going to be quite hard to chop out by hand. So you can use this wrong button, you can use the SLR for that. So let's just think about this. It's a fairly large mesh, so let's start something like 15 points because it's fairly dense, this model. We'll bring this up to 2.5 for starters. You can always bring it down afterwards. see that really takes out a lot of that garbage data that's just hanging around the model, especially the areas that didn't scan quite properly just due to colors or being on the wrong brightness setting. Some of those dark areas, for example, that's definitely much cleaner than when we started. And then just look at scan 4 in the same way. I haven't done too much manual cleanup to this one, so there's a few points that we probably should. Primarily something like this area. Looks like a fairly large feature that doesn't actually exist, so they're always a good candidate. One thing that's a bit annoying is you can't move the window after you've started cutting. You can always come back and do that afterwards. Just cut that, so once it's paused you can kind of move around and get a closer look. So again, looking at edges and angles as much as possible. See a bunch of crap in here. So space to unpause. Start. Some of these that really follow the model can be the worst ones in terms of just small areas that don't look great. They don't get picked up as nice. In this example, we'll just do some really quick ones. This wing looked like it had a fairly rough time. We've got that covered up on another scan, so let's be a bit more aggressive with that one. Looks like that was a bit blurred in the model. I probably should have taken that out in GW. Okay, cut it out. That one's not too bad. The other side was just a bit strange. If you find this model doesn't have a piece of information that you're going to want, it's better to be a bit more aggressive, cut it, rather than keep the garbage. Better off taking another scan and merging it in. Oh, it's not looking too bad, a bit of noise along here. Once you've got this done roughly, you can start testing some of the other items. Just pick some here. Again, always just keep rotating the model so you can see what should be there. It's better if you've got the model in front of you as a reference, but this one's so small I don't bother too much. Looking at it for a while now. Cool. This end of the model was stuck in a piece of blue tack, so there was no detail on that side, so happy for that all to go. But as a first pass, let's just click the tick. Again, make sure we've got the right one, just in case we've hit the segment in instead of segment out. You just want to make sure that you're deleting the right piece. That looks like garbage data, so delete. If you're using segment out, the segmented one will be the data you want to keep in most cases, so it becomes a bit easier. Cool, so let's just run through. We'll use the same filter values as we used on the last one. It might not be aggressive enough for this one given it's a bit messier, but on the whole doesn't look too bad. Those filters definitely make life a lot easier than manually removing everything. You can see there's some sections in here that didn't quite get cleaned up, so instead of going back and remeshing, I might just select that area. segment that out, and we'll just work on that piece by itself. So again, same filter, bring points down a bit, down to 1. Looks a bit better than me. So then you can get rid of the non-cleaned one and then merge the two together. Cool, and then if we look at the model as a whole, we'll find it looks a lot better than it used to, which is always good. A little bit of room for improvement there. I think it's close enough to show the mesh again. So again, take all of these scans together. Let's just merge them into a new scan. Cool. And then we'll go across to our PoissonRecon. 9 is probably high enough. If you're on a larger model, you find you can bump that up a little bit, but it does increase the processing time quite a lot. As we can see here, weight 2.0 looks okay. We can bring that down a bit. The main one here is this noise per sample. So as you remove some of the noise around it, you can bring this value down. As you can see here, it's got a bit of a range. So 1.0 for really noise-free, 5.0 for fairly noisy. So we might start at that end of the spectrum. And if you find there's a lot more noise, you can bring it up to that kind of 10 to 20 range. Cool. Make sure you've got output density on so that you can see how any interpolated data looks. Fairly processor intensive, but at least it's a fairly quick process. Cool, so we'll just turn off the original mesh points. So you can find a lot less crap hanging around the model, so certainly something that we could clean up a lot easier. But a lot more of those details are still here because we haven't taken them out as we've removed the detail. I'm pretty happy with what it's added in terms of from those very thin point clouds. It's done a pretty good job having cleaned up some of that crap that was hanging around. A little bit here in green that we'll probably clean up afterwards, just chop it out. But in terms of from very sparsely populated sections, it's made the shape fairly well. Comparing that to something like what we've got in JMStudio. Come back to here. Oh, this one. This is the output that we had previously. So you can see it does a fairly decent job in terms of getting the overall shape, but a lot of those details just won't show up when you come to the turning the mesh off. So no crisp details, etc. So definitely kind of meshing externally can be very beneficial. If we compare that to this, you can see a lot of these lines still exist. The splines that sit around this gun actually exist here on this model. So while we could probably clean up some of the flat surfaces to get rid of some of those smaller bumps, at least we've got that detail to work from. Again, a few points we missed in the cleanup along the back edge can easily be cut off. But you can see in a detail these double balls actually in there, because the other one just looks like a blob. You can see each of the missiles. There's some of the indents underneath the wing that just don't exist across here in any way that can be appreciable. So definitely a big advantage there. If you're finding it too difficult to work with the Poisson meshing in here, you can always export your cleaned up cloud and try to mesh that inside of JM or inside of Reverse Scan. So at least you've got some options. There are a few other programs that are similar, Mesh Mixer, etc., that you could look at. Similar tools, similar workflows, but this one seems fairly simple for me, not too resource intensive. So feel free to give it a go.